Hello, this is Peter Carter with the Climate Emergency Institute. A video on the 3rd of April 2020, the day before the IPCC's Working Group 3 mitigation report will be published. And so this video addresses getting the information we need from the IPCC AR6 scenarios. I've gone through them once before, but I'm going to go through them with respect to mitigation more so this time. They appear rather daunting, but they're not really. They can be understood fairly simply, and they're all important, of course, because these scenarios are what the Working Group 3 mitigation responses are based on. And there are some important problems with how the IPCC derives and uses the scenarios, and that's what I'll be looking at in the first section. This is an image that I posted on Facebook and Twitter yesterday, and this is a composite image from the IPCC Working Group 1, the science, showing all of the projections for the scenarios. So I'm going to be going through and explaining and hopefully make as clear as I can the IPCC 6 assessment scenarios, the various global emissions, the emissions of greenhouse gas scenarios, which lead to and are projected by the computer models to the global warming according to each scenario. And so I've put this on my website and I posted it. And this is from Working Group 1, the scenarios of the science, and these will be the basis of the Working Group 3 report, which is the mitigation. Now, before I go into, and I'm going to give you the results of the AR6, a huge word, actually many words of caution, because the real world temperature increases will be considerably higher than the IPCC AR6 model projections that are here and on which the mitigations will be based. They are underestimated, and therefore the mitigation in Working Group 3 is also going to be underestimated. The mitigation will have to be much more rapid, stringent, and aggressive than is indicated by the Working Group 3 mitigation report. So to start with, there's the climate sensitivity. There's been considerable discussion over the climate sensitivity over the past few years with the information from the very latest computer models. The IPCC assessment still uses the climate sensitivity, that's the temperature increase for a doubling of atmospheric CO2 of 3 degrees C, and it's been the same since 1990. From the latest models that are in the IPCC AR6 Working Group 1, the climate sensitivity is considerably higher than 3 degrees C. It's 3.8 degrees C. And here is the climate sensitivity from Working Group 1 science, and there is the climate sensitivity that the IPCC decided to stay on or stay with. Here's the actual climate sensitivity from the latest models, and it is 3.8 degrees C, not 3 degrees C. Now, what's going to happen? 3 degrees C still works for now, but as the cloud feedbacks increase, the positive amplifying cloud feedbacks increase with global surface warming, the climate sensitivity is going to increase, and it's going to increase progressively towards 3.8 degrees C. So there's a big fatal, flawed source of error there. Secondly, feedbacks. We've known about this forever, but the IPCC 6 assessment is still excluding the well-known, long-determined amplifying feedbacks of global surface warming. It still hasn't included them. Now, there are several large sources of amplifying feedback, we've known about them forever, that increase, the feedbacks increase with the degree and duration of warming. And as I say, not in the projections. Now, by 2 degrees C, these feedbacks will be adding extra emissions and forcing to the extent of increasing the global warming, of adding to the global warming. So it may be all right up to 2 degrees C, but it will not be all right from 2 degrees C. The amplifying feedbacks are large and they're well known. We have the peatlands. Peatlands are full of carbon. There's deep black earth, and they normally emit carbon, they normally emit methane, but as they're warmed up, they emit more methane. There's peatlands in the subarctic, huge, particularly in northern Canada, and there are peatlands in the tropical regions. There's peatlands in the Amazon, peatlands in the Central African rainforests, and also the far eastern forests. There are peatlands. The science has been very slow on projecting how much carbon that they will emit, how much more carbon they'll emit with global warming. But there is a recent paper that did just that, and so now we have the confirmation, but this is very clear from the theoretical science, that as you warm up the peatlands, they're going to emit more carbon. They're going to emit more methane, at least. And then there's the well-known one, the permafrost. Now, the permafrost thaw. Permafrost is being heated up, of course, in the Arctic, because the Arctic's heating up 3 times the global average, and it's thawing, and it's emitting all 3 greenhouse gases. It's emitting methane, but it's also emitting carbon dioxide, and it's also emitting nitrous oxide. Now, none of these. In addition to that, of course, there's what everybody knows because they're so dramatic, the forest fires. The forest fires in the subarctic boreal that go subpolar right around the planet. These are the largest forests on Earth, and they contain the most carbon on Earth. And they have, for several years, started to burn spontaneously. There's no help from human activities like is in the case of the Amazon rainforest and the Amazon fires. The boreal fires are being sparked by lightning, and actually the lightning is being increased by the global surface warming, global temperature increase. And these are huge fires, particularly in Siberia. And in Siberia now the fires are never going out. They call them zombie fires. They are smoldering away through the Arctic winter, and then when the Arctic summer comes, bang, up they come and form these huge fires that are clearly visible from space, and of course the satellites are recording that they're increasing as the years go by. They are a major source now of carbon dioxide. Now, none of these extra emissions, extra sources of warming, are included in the IPCC projections right up to 2100. That takes us to the other era, the carbon sinks. These scenarios assume the continued increase in carbon sinks of the land, the forests, and carbon sinks of the ocean. And yes, they have been increasing. The more CO2 the industry has been putting in the atmosphere, the more CO2 has been absorbed by the forests in photosynthesis and on the surface of the ocean, but in this case causing ocean acidification. And that in of itself is a thoroughly bad, catastrophic situation. The AR6 assessment assumes that this will just continue increasing up to the end of the century. But the fact is, and the IPCC has not caught up with this in its mitigation report, the fact is that these sinks have started to fail. Their efficiency is now declining. And this was reported and explained very well in the 6th Assessment Working Group 1, the science. It's also confirmed by the Global Carbon Project in their last annual report on the carbon exchange situation. So that's a huge and increasing source of error. These sources of errors increase with the global warming increase. So, 4th issue, the assumed successful CO2 removal. This is showing the IPCC AR6 scenario projections of the global emissions, and we're focusing on the best case scenarios here. That's these 2 lower and more rapid global emissions decline. The very, very best one is this one here called SSP 1.9, and the next best one is SSP 2.6. The 1.9 is projected to be at 1.4 degrees C by 2100, and the 2.6 is projected to be at 1.8 degrees C by 2100. However, this assumes the removal of CO2 from the air, from the atmosphere. In the case of the one which is projected to be below 1.5 C, the assumed successful removal starts around just after 2050. In the case of the next best one, the sub 2 degrees C by 2100, the CO2 assumed successful removal starts around 2075. Now the problem with that is nobody knows whether it's going to work or not. It certainly hasn't happened yet, despite decades of interest and concern and research by the science and the awareness. And it's not going to happen if we continue with the same world market economy that we're on, because there's no incentive for its development. We don't know if it could be successful, nor if it is successful, we don't know to what extent, how much CO2 it could remove, and for how long. The problem there is that to get down to these temperature limits, to these global warming limits, requires a lot of CO2 removal and requires it to continue for at least 100 years. And so when you see these temperature limits, 1.5 and 2, they depend on an assumption which is absolutely not verified, that after mid-century, we, the next generation, I guess, will be able to make that happen. All the indications are against that. There's no indication that it can happen successfully to this large extent. And so we have to get working on this right away. It makes no sense to work until 2050. We know we have to remove CO2 to keep down to actually 2 degrees C. And so we definitely have to do it. So because we don't know yet whether it works, because we're not doing it, we have to start doing it right away. And that means financing and resources from government. There needs a lot of financing and a lot of resources put in to the research and development of methods, technologies to remove CO2 from the air. And that has to be directly from the air, by direct air capture, called DAC, and not by the other alternative, which you'll read quite a lot about in the Working Group 3. That's called BECCS, Bioenergy Carbon Capture and Storage. It involves burning biomass, it involves burning trees, burning wood pellets, and there is absolutely no indication that that's going to get us down to zero CO2 emissions, which is what we have to get down to. The science has known that for many, many decades, and it's absolutely, definitely not safe. So it has to be direct air capture, DAC, please, not BECCS. So if we start on it right away, fully resources committed to the research and development, this would allow for assessing the effect and modifying the technology over time to get it better and get it working, hopefully, effectively and safely. And it's just common sense that obviously the sooner CO2 can be removed, along with the immediate rapid emissions decline, which should be going without saying because it's been definite for years and years, and the IPCC has said so, the sooner we get on this, the better. Lastly, there's this net zero buzzword that everybody's fallen for and jumping on this bandwagon, including the fossil fuel industries, including the big oil corporations. Well, it means it doesn't mean anything. It has to be defined if it's to mean anything at all. Otherwise, it's just what we call a boondoggle. It's just a way of encouraging the fossil fuel industry and governments to carry on burning more fossil fuels by saying, well, we can get down to net zero whenever we need to. No, you can't, because we don't even know whether we can remove CO2 from the air at all, and because our forest carbon sinks are beginning to fail. So it has to be defined by it has to be net zero, has to be defined, specified by zero carbon combustion. And again, the sooner the better we get down to zero carbon combustion, which simply means replacing all of the fossil fuel energy, including the natural gas, which is a lot worse than we thought it was because it emits methane as well as CO2. It's a fossil fuel, so it emits CO2 when it's burnt. And it must be zero carbon combustion because there must be none of this big increasing industry of biomass burning, of wood pellet burning, which is apparently also just as bad as coal, as is natural gas when you count in the methane emissions. So let's get net zero right. We've known for years it has to be by zero fossil fuels. That was specified, made very clear by the IPCC 1.5 degrees C report in 2018. And because we've got this horrid wood pellet biomass burning for energy industry, it has to be zero carbon combustion. And so, just to repeat as we go through these projections of global warming, they are big underestimates, and the longer we go in time and the higher the warming gets, the larger are those underestimates, and as I say, from several sources. And therefore, when we look at the Working Group 3 mitigation, as time goes by and temperatures increase, the mitigation is increasingly not going to be enough to prevent global climate catastrophe. The mitigation will have to be immediate, it'll have to be rapid, and it'll have to be a lot more stringent and aggressive than is indicated in the Working Group 3 mitigation report. So these are what are called SSP scenarios, shared socio-economic pathways, and the top two on here are the ones to focus on. The bottom ones are less important, they're sort of confirmation for the top ones, so sort of deeper science if you want. So on the left here we have the emissions, the projected emissions from 2015 to 2100, and the big one here is for CO2. Note this is actual CO2 emissions, not net CO2 emissions. And so the worst case is the top one here with the highest emissions, and the best case is the bottom one here with the lowest emissions. Also included is methane here, nitrous oxide here, and sulfate, which is a fossil fuel air pollutant, and this causes cooling. So the more SO2 air pollution is being emitted, the less heating we get because it has a cooling effect. Methane and nitrous oxide, of course, are greenhouse gases like CO2. They have a global warming effect. The contribution to methane of the warming is less than CO2, but it's quite substantial, at about a quarter of the heating from CO2. That's helpful to show that methane has to be rapidly reduced as well as CO2. That's always been the case, but the IPCC stressed that in its sixth assessment. Nitrous oxide is a greenhouse gas. It has the lowest contribution of the three gases to global heating, global surface warming. So here then is the projections from the IPCC of temperature increase, same scenarios corresponding to the emissions. So the emissions here cause the temperature increase here. So this is the worst case 8.5 temperature increase at the top, and at the bottom the best case emissions temperature increase. So this one here breaks down the scenarios to the various greenhouse gases, the amounts of greenhouse gases which are present in the particular scenarios for those people interested in that. The one thing is of particular interest, because it's shown rather easily, is the cooling effect of the aerosols. So each greenhouse gas, of course, adds to warming, but the air pollution aerosol contributes to cooling, and that's quite substantial in the higher emission scenarios. This is just a nice chart that I've modified slightly. So these are the projections as here, expressed in a written table. So the best case scenario 1.9 is at the top here, the worst case 8.5 is at the bottom here, and this is the near-term projection, mid-term projection, and end of the century projection. And so it is useful to follow these accurately with the numerics. Best case scenario would have ended up at 1.4 degrees C at the end of the century, but this scenario is no longer feasible. Emissions have been delayed for so long that it is now not feasible to reduce emissions fast enough to limit to 1.5 C. It may have been just fast enough in 2018 when the IPCC 1.5 degrees C came out, but it's now 2022, and those extra years have made 1.5, I am afraid, not feasible. We'll be there at around 2030. So we're left with 2.6, which the IPCC projects puts it at 1.8 degrees C at the end of the century. 1.5 degrees C is a globally disastrous temperature increase. 2 degrees C is a global human population, ecosystem, and planetary catastrophic increase. Both of these scenarios, best case scenarios, required an immediate rapid decline in emissions. This was clear on the previous assessments, and it was made very clear by the IPCC chair Hosung Lee at the Glasgow 2021 United Nations COP26 conference. Here is that most crucial quote, and I quote, "Global warming of 1.5 degrees C and 2 degrees C will be exceeded during this century unless immediate, rapid, and large-scale reductions in greenhouse gas emissions, especially of carbon dioxide and methane, occur." And that was the keynote address by the IPCC chair, Hosung Lee, at the ceremonial opening of COP26 in Glasgow, 31st of October 2021, and still that message has not gotten out. So I'm finishing off with 2 slides, the latest scientific reports on the very worst news of our already dire global climate emergency. This shows what I've already mentioned from the AR6 Working Group 1 science, that the efficiency of the land and ocean carbon sinks has started to decline, and the efficiency will continue to decline with increasing warming, and this will result in an additional increase in atmospheric CO2 concentration. This is from the Working Group 1. That's the illustration of these projections on the reduction in carbon sink efficiency. And this shows the situation at 1.4 degrees C, this at 1.8 degrees C, and this at 2.7 degrees C. And these are derived from the table that I've already shown on the temperature projections with respect to those 3 particular scenarios. The quote is that under scenarios with increasing CO2 emissions, the ocean and land carbon sinks are projected to be less effective at slowing the accumulation of CO2 in the atmosphere. Up to very recently, we know that the carbon sinks have been buffering the effect of our continued CO2 emissions to about 50%, which of course is a great deal. But we've also known that at some time things would begin to change, and those sinks will become saturated, and they would be less efficient at removing CO2 from the atmosphere. They would be able to remove less and less. Now, the last assessment in 2014, the AR5, projected that this would not occur. It would not be a concern. It should have always been a concern. It would not occur in at least until the end of this century. But here we are at 2022, and it's already starting to happen. So yet another example of the reality occurring many decades before the computer model had projected that things would start to get worse. So this is just another aspect of that, but a particularly severe aspect because it affects everything else. The quote here from the AR6 is, under scenarios with increasing CO2 emissions, the ocean and land carbon sinks are projected to be less effective at slowing the accumulation of CO2 in the atmosphere. So this shows the situation at 1.4 degrees C, this higher at 1.8 degrees C, and this at 2.7 degrees C. The sinks are still absorbing taken up CO2, but they are doing it at a reducing rate. So this is the amount of CO2 left in the atmosphere at 1.4 C, much more left in the atmosphere at 1.8, and very much more left in the atmosphere at 2.7 C. So the effect of the reduced efficiency of the carbon sinks is further accelerating the already accelerating atmospheric CO2 concentration. This here is from the Global Carbon Project. This is their last report, November 2021. This also a vital confirmation of the carbon sink situation was missed. The quote here from the Global Carbon Project is, process models suggest that increasing atmospheric CO2 drives the land and ocean sinks, while climate change reduces the carbon sinks. And globally, during the 2011 to 2020 decade, climate change reduced the land sink by about 15% and the ocean sink by about 5%. That's a lot. And it is going to get worse. And that makes the emergency much worse, much more dire. And this is the Global Carbon Project illustration of that particular data. And so we come to the very last slide. And this is on the current state situation with regards to global CO2 emissions. And this shows the AR6 scenarios on global CO2 emissions that we've seen already. I've cut it down to focus on the present time. What has happened is that global CO2 emissions have rebounded to a record high in 2021. And this information was provided by the International Energy Agency. Their last such report, March last month of 2022. And so what's happened is that, and this shows the recent record of global CO2 emissions, the actual record, with the COVID pause in the world economy, there was a sharp decline in CO2 emissions, but there's been just a sharp increase back to what is now a new record high of CO2 emissions. The quote I want to bring your particular attention to from the IEA is, this puts 2021 above 2010 as the largest ever year-on-year increase in energy-related CO2 emissions. Of course, what happened here was that the governments in their economic recovery put more recovery funds into the fossil fuel industry than they put into the clean renewable energy industry, which was an absolutely terrible, terrible thing to do against all advice. And of course, at the same time, the big world banks have been continuing to finance more fossil fuel extraction projects. And in addition, with the carbon sinks efficiency beginning to decline, the effect of this will be to add further CO2 emissions to this now rapid increase in emissions, which is certainly now outpacing by a big degree what has to happen for our very survival, which is that global emissions had to have been declining by 2020, as we've already seen from the Working Group 1 on these projections. And so we have yet more and more evidence piling up to confirm for sure what the IPCC has been saying for some years, which is that global emissions of greenhouse gases, particularly CO2, but also methane, have to be put into immediate, rapid decline. This should have happened by 2020, and instead of that, with our governments and our global banks financing more fossil fuel energy, we are going completely in the opposite direction. And that is a dead end. That's a dead end for humanity, a dead end for most of life on this planet. And I'm doing my best with the scientific evidence from the IPCC to get everyone, governments, financing, banks, scientific associations, everybody, to compel the governments to do what they have to do for our survival now. And they can easily do this, is to put global emissions into immediate decline rapidly. So this is what it's all about. It's all our beautiful young children in the world, as well as the beauty in the world, of the beauty of nature, which is in fast decline also. And I like this particular banner, particularly it says, "Our future is not negotiable." And morally, ethically, humanly, spiritually, in every way, the future of our children is not negotiable.